Hello, Professor. I hope you're doing very well. My name is Tomás Vintimilla, and I will present my ethical dilemma, which in this case is bias in algorithmic content recommendation systems. I'm going to quickly put a 2-minute timer so that I try to not go beyond the time limit, and let's begin. So a bit of introduction and context. Algorithmic content recommendation systems have become very popular nowadays. You could say ubiquitous, and they are definitely shaping the content we consume online. The way in which these systems work is that they create personalized recommendations tailored to individuals using their user preferences by using AI algorithms. We can see these engines in platforms such as Netflix, on news feeds, Instagram, TikTok, etc., etc. Any place where you interact with content basically uses specialized recommendation systems. So the problem here is the inherent biases present in algorithmic content recommendation systems. This problem directly affects technology by influencing the algorithm's design and deployment, individuals by shaping their online experiences and perceptions, and lastly, society as well by affecting public discourse and social cohesion. So the critical analysis, it is really important to consider this bias because it raises ethical concerns regarding fairness, transparency, and the right to access diverse viewpoints. And also from a legal standpoint, it may infringe upon users' rights to privacy and freedom of expression. So in order to analyze this problem further, I am going to present a few examples with their corresponding solutions. I chose not to offer a whole solution for the complete problem because this is too big of a scope. So I chose to focus on two specific examples, which are presented in a paper I found in Towards Data Science, and I will present them right now. So the first one is clickbait bias. This bias is sensational or misleading headlines or video thumbnails designed to grab a user's attention and then entice them to click without providing any real value. So when you are surfing through YouTube and you see these super catchy and eye like attractive photos, they're usually clickbait. And the solution for this is to use weighted logistic regression, which uses weights as the watch time for positive training examples and unity for the negative ones. So by this, the model predicts the actual video watch times and makes a rank of them according to the recommendations. The end goal of this is prioritize videos which are expected to be watched longer and placing clickbait videos lower in the list. And then the second example is duration bias, which is the bias where longer videos always have a tendency to be watched for a longer time simply because they are longer and not because they are more relevant. And the solution for this problem is a quantile-based watch time prediction model. It is a bit similar to the last one I mentioned, but in this case, the author buckets all the video duration times into quantiles and then bucket all watch times within a duration bucket into quantiles as well, as you can see in the picture below, where they have the example of two videos, one which is 120 minutes long and one which is 20 seconds. But each one of them has a watch time of 10 seconds. Of course, this watch time will have a very different effect in both, because if you watch 10 seconds of a 120-minute video, you basically watch nothing of it. But if you watch 10 seconds of a 10-second video, you watch it completely. So thanks to this, it is able to predict and rank the actual watch times, and it also leads to an overall rank of these videos. And the results of these proposals showed to improve user watch times in the end. So this is it for now. Thank you very much for your attention, and I hope to see you soon.